Okay, so 3 minutes past the hour. So welcome everyone. Welcome you to this joint webinar of Variscite and ICS. The focus today will be on overcoming hardware and software challenges, and we'll review a medical device case study. The speakers today will be Lisandro Perez Meyer, which is a software engineer in ICS, and myself, Tal Semo, Managing Directors of Sales and Marketing for Variscite in the Americas. So with not too much words, let's start. So we'll start with some introduction of Variscite. Then we'll review a little bit on the case study. We explain what is the project and how we actually selected the hardware configuration for this project. Then we'll have a review on ICS and we'll review the software side of the specific project. And then we'll give some around 10 minutes for open questions. So a few words about Variscite. So Variscite next year celebrates 20 years in this SOM business. We are today one of the companies with extensive customer base and pipeline. We provide stable supply using our own internal production facilities. We give full R&D support to our customers 24 hours. And we are the only SOM vendor today that is NXP Platinum partner, which is great for two main reasons. First of all, we get early access to NXP platforms. We can actually develop the SOM together with them. And second is around the supply chain and availability of processors. We also provide the most diverse IMX-based product portfolio, and we meet all the highest quality standards, regulatory requirements, and also the ISO medical as well, the 13485. We have a lot of partners for complete end-to-end solution. Just a little bit on our system model. So we provide two pin-to-pin compatible product families. We'll review them in a minute. We provide full customizations of our SOM, so that allows our customers to actually customize the SOM, select the relevant features, and pay only for the features they need. We can guarantee 100% yield out of our warehouse because we test all the SOMs, 100% of the SOM are being functional tests. So all the SOMs that leave our warehouse were totally tested and approved. We provide production-ready hardware and software to ease of use of the integration of the SOMs. Our SOMs were tested and used by hundreds of customers, so they are proven in high reliability and provide very low risk in designing them into a product. We provide huge free support for our customers through our customer portal and ticketing system, to our GitHub, to the VariWiki, and we provide a lot of reference documentation like CAD, 3D drawing, and everything. And of course, we will provide robust longevity of up to 15 years on all our hardware and software. So I discussed about the pin-to-pin family. So we have actually two families. The first family is the VarSOM family, which is based on an SODIMM edge connector. And the second family, as you can see, this is a very large family from low end, the 6QL, and up to the latest IMX8 processor released by NXP. Our second family is the Dart pin-to-pin family, which is mainly for product that has size limitation. These SOMs are smaller and use a board-to-board connector, so there is no additional penalty you need to pay for an edge connector. Okay, so these two families are pin-to-pin compatible, and of course we continue and grow these families every time we release a new SOM based on a new processor from NXP. So why to use the system? So there are several reasons. Of course, I think the main one is faster time to market. Okay, it allows you to start with software and hardware that are ready, and you can actually focus on designing your own application and your proprietary. It reduces the R&D cost. less NRE costs because again, less development on the software and embedded side. It's a proven solution, tested and already been integrated by hundreds of customers. It allows you easy development and easy integration and easy access to the latest technology. So these are the main reasons to use a system module. Okay, so after we did the introduction to Variscite, let's start and review the current case study. And a few words about this product, okay? So we're talking about a medical device company in this case. They are designing a laser-based device. This device is subject to FDA approval. It should be submitted to the FDA. They were looking for a partner which complies with the medical ISO 13485. This was a mandatory requirement. The issue of traceability up to the component level is critical to FDA submission. And of course, as a medical device company which keep product in the field for a long duration, these specific customers are looking for extended longevity. Okay. So these were the main reason and that brought this specific customer to Variscite. In aspects of hardware, what were the hardware requirements? So this specific customer is designing a new product that has it needs multi-core solution for high processing needs. It's also going to integrate AI algorithms on this specific product. So he's looking for a separate NPU to run AI. This specific product also has a size constraint. Okay, so the size that was actually allocated for the SOM is very minimal. This specific product also requires two displays, one HDMI display and the second one LVDS interface. Very sophisticated GUI. So they need very strong GPUs. There's intense graphics involved. They required MIPI CSI camera input for this specific solution, USB 3. They also required dual Ethernet gigabit PHY. And also they were interested in a real-time processor to manage some real-time peripherals, okay? And of course, we talk about longevity. The requirements was as a minimum for 10 years longevity. Okay, and after we analyzed all this information together with the customer, we actually came to this solution, which is SOM based on an IMX8M Plus system module. As we discussed, we have two types. Okay, we have the Dart MX8M Plus and the VarSOM MX8M Plus. And in this case, the customer was leaning towards the Dart solution because of the size constraint. As you can see here, the difference of the edge connector on the VarSOM solution connect to both on the Dart solution. So basically, this is includes the SOM, of course, the IMX8M Plus Cortex A53 from NXP up to 1.8 gigahertz with a co-processor, real-time processor, Cortex M7 up to 800 megahertz. The IMX8M Plus also has an AI and machine learning NPU. It supports HDMI display, LVDS, and DSI interfaces. It includes Vivante GC7000 ultralight and some other 2D and 3D accelerators. Video encode and decode of 1080p, dual gigabit internet, and CAN and CAN FD as well. It supports dual MIPI CSI camera inputs. There is a built-in certified single or dual band Wi-Fi with Bluetooth 5.2. It supports up to 4 gigabytes of LPDDR4 RAM and up to 64 gigabytes of eMMC. And it can support up to a full industrial grade of -40 to 85, and longevity is 15 years. So this was a perfect match for this specific customer needs, both size-wise, longevity, and hardware features. Okay, now I'll give the control to Lisandro that will take us through the software aspects of this specific project. So Lisandro, the stage is yours.
Good morning, everyone. Thanks, Tol, and welcome everyone to the webinar. We are Integrated Computer Solutions, and we have been around since late 80s. We deliver innovative software solutions with a full suite of services to accelerate development of successful next-generation products. ICS Design Studio Boston UX specializes in intuitive touchscreen and multimodal interfaces for high-impact embedded and connected devices. We are a dedicated method practice, but our portfolio includes everything from professional restaurant equipment to autonomous vehicles. ICS and Boston UX are headquartered outside Boston in Waltham, Massachusetts, with offices in California, Canada, and Europe. So, next slide, please. Okay, so we selected the board, and it's time to start thinking on the development process on it. We will go through some of the challenges we face when developing a medical device. Developing such a device implies complying with certain standards, starting with IEC medical devices and medical device software lifecycle processes. Depending on the nature of the medical device being designed, we might need to take into account other standards. An example of this could be IEC 60801 Parts 1A, which is a collateral standard named General Requirements, Test and Guidance for Alarm Systems in Medical Electric Equipment and Medical Electrical Systems, which, as you can imagine, standardizes how an alarm should be and behave. So if the product will produce an alarm, we also need to take this standard into account. For the board to function, we need to create an operative system that provides all the necessary functionality for our project. We will also produce a software development kit from that build, so developers can create the required applications to run on the board. Finally, let's not forget about the user experience necessary to make a product stand between others. It is not enough to have the best functionality in the market, it is also important that users find it easy and comfortable to work with. Next slide, please. Let's take a brief look at these two IEC standards. Note the first word, process. As we will see in the next slides, this is the core of a medical device. The IEC standards require a process in order to improve the safety of a device, analyzing normal and abnormal use cases in order to determine risks and mitigate them. This process must start with the project itself, and it will be part of its whole life cycle. Mitigation can happen in various ways, modifying hardware, adding software checks, and even by placing labels in the product with appropriate warnings. All these risks and its mitigations must be fully documented, as they will be required by regulatory authorities. From now on, we will refer to these concepts as the process. Next slide, please. So the previous IEC standard has a general scope. This standard comes to cover the software aspects of a medical device. Software in itself is quite different to hardware. If you have a medical device with a sensor that must get into contact with a human being, one of the normal tests a manufacturer needs to do in order to pass regulatory requirements is to turn on the device and put the sensor inside a standard specified saline solution and measure the total current that might or not get through it. Yes, this might be a destructive test for the sensor, but the test is designed to assess the risk of electrocuting a human being. With software, it is not possible to test each and every logical combination that might produce a risk. So the standard focuses on the life cycle process. Note, it does not impose a specific process. Instead, it asks the manufacturer to define a process that fulfills the standard requirements and to follow it at all times. This is an interesting situation, as the process can be designed to fit the manufacturer as much as possible. But on the other hand, a new process will require checking that it produces all the required documentation in order to present it to regulatory authorities. This standard is quite lengthy, but allow me to give an example with the safety classification of a device. A proper safety classification is crucial. If the selected classification results lesser than the required by regulations, You will need to work hard in order to add all the necessary information and procedures in your process that could have been there from the beginning. On the other hand, if you select a classification stricter than what your device really requires, you will be investing more time and money than required. As you can guess, the more risk exists for a human being, either a patient or the operator, the more detailed the process and documentation must be. This standard also adds another concept, software of unknown provenance, also abbreviated as SOAP. This is the equivalent as of the shelf in the hardware world. SOAP is software that has not been developed with a known software development process or methodology, or which has unknown or no safety-related properties. It is not prohibited to use SOAP, but additional controls are needed and the risks need to be taken into account. Next slide, please. So, now here is one of the key points of this presentation. What makes our project a medical project is the process. Let me give you an example with an eye tracker. Eye trackers are devices that try to interpret where someone is looking by capturing images of the user's eyes, normally by using cameras like the one on the boards I presented us. Tracking eyes in this way is a process of retrieving images, determining where the eyes are and where they are looking to. Now, this can be used for multiple purposes, such as video games, controlling a 3D interface. For example, think of an architect reviewing a building's 3D model, or maybe even trying to diagnose some condition on a patient. The core of the image processing required to track the eyes is the same. The difference between a medical and non-medical development is the process that allows the manufacturer to analyze, specify, develop, and evaluate the usability of a medical device as it relates to safety. So here you have two tips. The first one, be sure to document everything from the very first moment, every test, every decision made. The second one, start the risk analysis as soon as possible. Always have possible risks in mind. Note them down. Next slide, please. These are things that helps the process to meet the standards criteria. A common development methodology helps to get the most out of the software development process. Common architecture, validated tools and dependencies, and common code libraries allows to easily revamp previous work, reducing the development and documentation time. Do not leave cybersecurity for later. It's part of the risks that need to be analyzed. And yes, even if your device will not connect to the internet. And remember that a happy user is a happy customer. Incorporate the usability team during the whole process. Next slide, please. We have selected a board and are ready to start the development process. From now on, you might find many of these steps very similar or even the same as with a normal non-medical project, but beware of the process. One of the first steps into creating a device is the platform setup, creating an operating system that allows your product to use the sensors required, analyze the data they produce, interact with the user. In other words, prepare the system for the applications that need to run on it. Sometimes we need to set up a different displays from the one in the development kit. Sometimes we need to use a special bus for communications. Think, for example, on CAN, SPI, I2C, Wi-Fi, Bluetooth, you name it. So here's another trick. Try to prepare a test for each of the above, especially the sensors. They will not only help you understand their capabilities sooner, they will also help you provide a proper quality assurance during manufacturing. Another useful tip is to try to select hardware that has already been certified. Sometimes you might need to recertify them because you're using them, for example, in a non-certified PCB or in some other condition that requires recertification. But having a previous certificate always helps. As an example of this, think on a board that has done more than one antenna for different purposes, like Wi-Fi and 4G. Even if both are already certified, the fact of using them as a part of the requires recertification to check that one does not affect the other in a risky way. As an anecdote, I was once able to avoid recertification because I proved that they were not going to be working at the same time, thus they will not interfere one another. Next slide. On the software side, Variscite provides us with a default Yocto image, which showcases the amazing number of features the board supports. Normally, a project will not use each and every feature. For example, not everyone will use the CAN transceiver. So start by reducing the software to what the project really requires. Then we start to customize the experience. Do we need a specific software development kit like Kit 6, which is not yet the default kit version in Variscite's offering? You might need to integrate a specific peripheral with Kit 6, like we did with the camera chosen by our client. Or maybe you need your device to be able to print. Be sure to do all the changes in your own Yocto layer. You might even want to have your own repo manifest repository as a clone of Variscite's one with a branch for your development. This makes the development cleaner and allows much easier updates on the base of Variscite OS. Building Yocto requires build power. Do not hesitate in getting a powerful build server. This will speed up the development process. And document. I personally like to document the new layer in the layer itself by using Markdown, so I can treat documentation as code. But what really matters is that you get the proper documentation following the process, not the way you achieve it. Next slide, please. During the development process, do not forget about the factory setup process. You will need to flash your image and most probably provide each one with its own characteristics, like a proper SSL TLS pair or a password or both. Keeping customers happy is key, and admin fleet management might help you with that. Gather information from devices. What information depends, of course, on the device, but being warned by the manufacturer that your device might need servicing soon is a much better experience than the client asking for maintenance once the device is already malfunctioning. Saving your client's time and money is earning their trust. Always consider updates. Even if your device will not be able to connect to the internet, be sure that you have a way to provide updates for it. Next slide, please. A Yocto build requires quite a lot of time and space, so it's normally preferable to provide your developers with an SDK tailored for your device, so they can easily start working without the need of doing a full Yocto build. It also provides a way to avoid developers adding soap without going the full process. Having a common IDE is a great idea because it reduces the amount of tooling that needs to be documented. Yes, you will need to document this too. Better yet, if the IDE is your team's preferred one, integrate the SDK into the IDE. This will help you reduce development time. And yet again, yes, of course, document everything. This will not only help regulations, but also speeding up new developers in the team. Next slide, please. So far, we have been talking on everything that prepares you to develop the core of your device, the main application. A normal project kickoff will involve a proof of concept application that has access to your sensors, protocol, passes, and multimedia capabilities, just to name a few. Note that this might or not be different from the test I mentioned earlier. Think, for example, on integration tests. From there, we can grow to the full-fledged application, always following the processes defined earlier, producing the right documentation for the manufacturer to present at the regulatory office. Of course, this is a product, so we need to ensure that we provide its user an awesome experience. And finally, did I mention documentation? Yes, I keep insisting on this point. The best documentation system will be the one that allows both developers to easily contribute to it and regulatory officers to easily audit it. That, of course, depends on the process you follow for your product. We can go to the next slide, please.
Thank you, Lisandro, for taking us through the software part of this webinar. And next, there's several questions that I'll ask you, okay? The first question is, do medical devices have network security needs that had to be accounted for in the OS design process? So any network security needs as part of the design of the operation system?
Well, you need to always think a medical device from the risk point of view. So if your medical device has a network, the risk of being attacked by someone outside of it is a real risk. Imagine you being attacked while you're doing a very important task with your device. So yes, this has to be accounted for it in the OS design process, but not only there, in the OS design process, in the application process, everything that can go through network should be audited or have a correct security.
Okay, thank you, Sandro. And the next question is as follows. For the software device, is it necessary to fulfill any essential or performance requirements? If so, which standards are followed for the same? So any
That's
specific, go ahead.
Yes, that's quite a good question. The one that the requirements are really defined by the manufacturer. So it's the manufacturer that decides which are the, for example, the essential performance requirement, and so it lies on the manufacturer to check that the device will be able to fulfill them. For example, if your medical application is just software, because it could happen, your medical application is just software, you might require the user installing the software that your device has, for example, certain amount of CPU, certain amount of RAM, and should have at least this version of this specific operating system. But remember, the requirements are always done by the manufacturer, except maybe in some specific cases, like for example, there's those little tiny devices that measure the oxygen in blood. Those have a specific standard for them. So it really depends, in those specific cases, it really depends on what you are trying to achieve, what your device does. But normally, most of the requirements are set up by the manufacturer.
Okay, thanks, Sandro. I see the last question. Did you consider customizing a standard Linux distribution instead of using Yocto?
Yes, and it's doable. The difference between, in fact, you could actually combine both. I have, for example, used Debian on certain boards, and it works, but it makes some things more complicated, actually. With Yocto, you can really customize the base OS up to the point where that really does what you need. You can do that with Debian, but you need to understand how Debian works, how to recompile Debian packages. You need to do most of that by hand. It's not as straightforward as with Yocto. In both cases, really require people knowing how to achieve that, and that's why Variscite, for example, offers a Yocto solution, because that's really a good way of doing it.
Yeah, I will add on that, Lisandro, that Variscite provide full OS support. So let's say for the specific IMX8 base storm, we support Linux, Yocto, Debian. So our BSP, we have Yocto, Debian, Ubuntu, and we support also Android, okay? So basically, it's a decision of the developer. He can go which route he likes to go on, or what he's familiar with, okay? So all options are available from Variscite software, okay?
There's another thing quite interesting in that question, which is SOAP, unknown provenance. Sometimes Yocto makes it easier to list all the SOAP that you're using in your product, and sometimes and using a distribution like Debian might not be the best fit for that in a medical device. For other devices, it could just go pretty well.
Okay. Thanks. There is one last question I see, and see if you can answer that. But the question is, how do you create edge cases when you test, when you test your software?
Well, that really depends. We normally have two sets of tests on software: the unit test that check every unit in the software, and the integrity test that try to check more than one unit at the same time. Both necessary, and edge cases really depend on two things. One is how much time are you willing to put into testing, and the second one is the risk associated with your product. When we're talking about medical devices, if you have a device that can risk the life of the operator or the patient, the standard requires you to do quite a lot of testing. So at that point, you want to try to figure out the most cases possible. Of course, you can always leave something behind because you might forget, you might not notice it. That's normal. What the standard really wants you to achieve is that you are trying hard to do it. If you find a new issue once the product is in your customer's hand, it can happen, and the process tells you that you need to have a process to deal with that. So edge cases really depend a lot on the product and on the risk analysis done for it.
Yeah. Yes, and I think that on top of it, like I said, that you basically to test edge cases, probably in most cases you need to use, as you said, part of unit test or to some kind of using an external simulator, I think.
Right.
Okay. I see. I think we have time for last question. So the question that is in terms of validation and regulatory standards, is something non-standard for UI like Android is problematic against, let's say, Yocto or Qt? So the question is that Yocto is more easy to show that you comply with regulatory standards in compared to Android or Qt, for example?
That's another good question. Really, as I mentioned earlier, Android and Linux will really be part of the SOAP software of unknown provenance. So as long as you can check, you can list the SOAP and you can do some testing that to know that it fulfills your requirements, it should be good to use. Now, if you ask me for a medical device, I will no doubt use Yocto instead of Android because Android is more targeted massive consume, and you can really get very good interfaces, as good as Android, and even better with Yocto than with Android. Normally people use Android because sometimes they get developers easier, sometimes because they are used to the way they are being developed. But you can really have amazing interfaces using Yocto too.
Okay. Okay, thank you, Sandro. This was the last question. So I just want to conclude and thank everyone for joining this webinar. The record of this webinar will be shared with all participants following later during this week. Okay, so again, thank you everyone. Thank you, Sandro, and have a great rest of your day.
Thank you, everyone.
Bye bye.
Bye bye.